This is lesson 5.2 of accelerated geometry, and it's called exterior angles of a polygon. So it says in our last lesson, 5.1, you discovered a formula for the sum of the measures of the interior angles of any convex polygon, which was n minus 2 in parentheses times 180. In this lesson, you will discover a formula for the sum of the measures of the exterior angles of a convex polygon. So if we were in class, I would have you do an investigation in groups. But we are not in class right now, and so therefore I'm going to show you what you would find out in that investigation. So I'll come over here to Sketchpad, and I have already drawn a four-sided figure. So this four-sided figure is B, C, E, G. And I extended each of the sides of that four-sided figure to create exterior angles. So this exterior angle is angle ABC, and Sketchpad measures it to be 84.17 degrees. Same thing with this one. I extended this side, and I get this as the exterior angle. I extend this side. Here is the measure of that exterior angle. I extend that side, I get another exterior angle with that measurement. Next thing I wanted to do is, the conjecture is asking me to find out what the sum is of those exterior angles. So I did that over here, and look what I find out. The exterior angles ABC, DCE, FEG, and BGH all add up to be 360. So that's kind of an interesting fact. Okay, so the inside here, the inside angles add up to be 360, and the exterior angles also add up to be 360. So I wonder if there's a relationship between them. So let's go further. So the next window, I drew a five-sided figure. So five-sided figures on the inside, the interior angles add up to be 540. So I want to know, is this the same relationship that I had on the last slide? So again, I created all these exterior angles, then I measured all the exterior angles, and then I added them up. Not 540 at all. 360. So let's go back to this first. When I had a four-sided figure, the exterior angles had a sum of 360. When I have a five-sided figure, the exterior angles were 360 degrees. Okay, let's do a six-sided figure. So a six-sided figure, the interior angles are 720, 6 minus 2, which is 4 times 180. So that would be 720 degrees. Okay, I created again the exterior angles. All of these are the sums of those exterior angles. Okay, then I added those up. So I have that hidden. I'll bring it forward now. 360 again. So it doesn't seem like the interior angle sum equals the exterior angle sum. It seems like every time I have a polygon, no matter how many sides it has, the exterior angles always add up to be 360 degrees. So I'm going to put that down, and I'm going to come over here. And here is conjecture number 32 for your conjecture list. For any polygon, the sum of the measures of a set of exterior angles is always 360 degrees. Doesn't matter what size the polygon is, how many sides it has. The exterior angles always add up to be 360 degrees. Okay, the next thing, what if I have a regular polygon? So I have a polygon that has all equal angles and equal sides, but even if it just had equal angles, that would be fine. I know that these exterior angles are going to be a sum of 360. So if they're a sum of 360 and there are 6 of them, 360 divided by 6 would give me 60 each. So I take the 360 that are the sum of the exterior angles of any polygon, and if I divide by how many exterior angles there are, which is the same thing as the number of sides that there are, I will get the measure of one of the angles if I have a regular polygon or a polygon that is equiangular. So now if I go down here and come to this page of our notes, this is after conjecture number 32 on your list. It's called the exterior angle of a regular polygon. It does not have its own number. The measure of one exterior angle of an equiangular polygon with n sides is always going to be 360 divided by n, which is the number of sides.